and they're not really given the opportunity to explore the material more in depth because they're going to be on to the next assignment and next deadline. So there are two quotes that I really like about curiosity. One by Albert Einstein said that I have no special talent, I am only passionately curious. And another one by Aaron Swartz said, be curious, read widely, try new things. What people call intelligence just boils down to curiosity. Basically, formal education, as I said, studying for exams and homework deadlines, it kind of detracts from the true learning experience and things that really develop a lifelong desire to learn. Basically, the studying for exams and homework deadlines stifle that curiosity, which will lead to the lifelong and desire to learn. And there's the slide that tells that. I think the curiosity flourishes in a no-stress environment, free of deadlines. And this leads to your...
So following on Tim's introduction, the basic idea here is that the way we structure education typically is very formal. It's a bit too formal for bringing you to the actual passionate enjoyment of what you're learning. And when we miss that passionate engagement, then you don't learn as much as you could have. So the place where you want to be, or we as educators and people interested in education want to be, is that you should be so engaged in studying that you will be asking for more and say, let me do more, as opposed to, I'm tired of this assignment, I just want to go to the next thing. And so, to Tim's point, is that when the structure is so much, when we try to control it too much and tell you that you have to do this and that exam and that specific time, we squeeze the pleasure out of the learning and convert it into work, and that makes it harder for you to learn. So we need the opportunity to have very engaged, very enthusiastic learning. So in parallel to the classroom, we have opportunities to have informal education, and informal education is very powerful because you have that low stress environment, and having low stress is really important for learning. You have the enjoyment of sharing things that you know with your friends, learning things by opening the box and see how it works. So that very natural characteristic, so coming back to the quotes on curiosity, that's really how we learn. And it's very hard to trigger that in a classroom. We as educators have a hard time doing that to 50 students at the same time. But when you are interacting in an open space with other people, there are more opportunities for having that occur spontaneously. And an important element of that environment is imperfection. Because when you are in a space that is too perfect, you don't want to break anything. You don't want to break the rules. You want to follow the path. You don't want to make the floor dirty. And then you don't take risks. You are not in a comfortable environment. So imperfection is something that invites you to, you really want to go and fix that typo because it's bothering you. And that desire of going and fixing it engages you into doing something. See, if the slide was perfect, then you would already ignore the slide and you would be thinking about the lunch and the things that you're going to do tomorrow. But the imperfection of this thing here keeps you motivated to do that little effect. Not that the imperfection is small, it's just one letter. So it also brings that level of, it will be so easy to fix. It will not take you hours. You don't have to work during the weekend to do it. So, why not fix it? And it comes down to something that Isaac Asimov points out, and is that perfect products, those shiny iPads, they are beautiful, but this is not what you want to give to engineering students. Engineering students should have bulky things that they can open, break, repair, rip apart, without having any feeling of guilt or responsibility whatsoever. So you want to go back to that spontaneous environment where if it breaks, I know, it was old and who cares. But in the process, then you can learn, because you are not constrained by the responsibility of protecting the thing that you bought for $800. So this is what the Raspberry Pi is. And as Tim pointed out, this started in Cambridge as a result of looking at the registration for computer science students. They started noticing that they were getting less computer science students and lower quality of aspirants. And when they were looking at why, what they realized is that, well, we have all these shiny devices, computers are everywhere, but now they are very close, they are too perfect. And they are too expensive for you to break them apart. You cannot open an iPad without breaking it. So they look back at how people, young like me, learned in the 80s to use computers. And we have these toys, like the Commodore 64 and other machines you have never heard of, that were that kind of thing. They were cheap enough that if you break it and not suffer too much. You could actually open them with a screwdriver, you could see how it worked inside, and then you will learn. And there were no homework and exams on those. It was something that you will be doing for the pleasure of working with it. So they look back at how can we give this current generation the same experience that other people had in the 80s with the earliest computers, the earliest personal computers. And it comes down to simplify the computer again. It has to be something where you can see where the memory is, where the chip is, what's the processor, what is the port. That is very hard to see in a modern computer. Modern computers are so sophisticated that you open the box and it still doesn't tell you anything. This is the magic of the Raspberry Pi. They work very hard to make sure they were cheap enough that if it breaks, you don't care. You will just maybe buy another one. And it will cost you maybe a week of lunch money to get another one. And you can trade it. You can get a cheaper one that is only $25. So because it's that cheap device that you can get easily, and you're not afraid to break it, then you go back to that low stress environment where you say, well, let's see how this works. And if it breaks, that's okay. Now, it's a very decent computer. This is what was my desktop 10 years ago. So it looks like a toy, but it's not really a toy. It's a very decent computer. You can perfectly run a web server on it, an entertainment center with it. So it has 512 meg of RAM. It's a lot smaller than your cell phone, I know, but it's still a decent computer. And ironically, so it has this HDMI high resolution video because most TVs today use this kind of inputs. When they designed the Raspberry Pi, they wanted to make sure that you could use it with what you have at home right now. So the power supply, you can use the power supply of your cell phone to feed it. You can connect it to your TV, and you can connect your current keyboard. So once you get your Raspberry Pi in your stocking for Christmas, you're ready to go. You don't have to start ordering stuff. Now you can order stuff, and there are many other things that you can put with it, but you're ready to run with things that you have at home.
I think one of the other really cool things about the Raspberry Pi is that it has these what's called header pins on it. And header pins allow you to interface it with other interesting devices. You can make a robot out of it, or you can connect LEDs and make LEDs flash in different patterns, or you can. Basically, the idea behind it is it makes it very versatile, and you can do a lot of different projects with it.
Yeah, I mean, if you Google for Raspberry Pi, you will find hundreds, thousands of projects out there that are just fascinating. Because the smaller size of the board makes such that when you get one, your first reaction is, let's see what I can get with this thing. And it's a challenge to see what you can get away with $35 computer. And you will see projects that are really go back to the basics of engineering, understanding how things work. One of the projects that is my favorite is somebody took a cable, 5 inches cable, plug it into one of those pins, and start flipping it on and off with a Python script. And what happened is that these computers are so fast that by doing that, you have the equivalent of a radio oscillator. So by just doing that, he was running an FM radio from his Raspberry Pi with a simple cable. And so that's the beauty of these kind of devices. It brings you back to the essential concepts of engineering that you can grasp, you can play with it, and nobody gets hurt. So that's now it's not the professional radio that you want, but if you need to explain to somebody how radio works, that's a very tangible way to do it with a chip device. Now it has audio output, so they are very focused on the notion that people like games. And games and learning are very closely related. So one of the first applications that you will see in a Raspberry Pi are on how to make games with Python scripts and the Scratch program. Because there has to be, the learning experience has to be enjoyable. And it's work, but it has to be work that you're enjoying because it's not under the pressure of, I have to finish this by tomorrow, otherwise I don't get my grade. So this is Commodore 64. If you ever saw that, this is what it was the Raspberry Pi 20 years ago. It was a toy. You couldn't find it in a computer store because the computer stores were for universities and the Defense Department. This was sold in toy stores. And you connected to your normal TV and you could play small video games with it. But it's a very decent computer. It has 64K of RAM. You probably no one don't understand today why somebody will measure RAM in Ks. But it used to be that way. And it's again part of the challenge because you start thinking, what can I get away with this device? It's a challenge of how much can I do with these limited resources.
You can even connect a modem to it.
You can
pretty cool for the
do it,
time.
yep. Drive robots, do all these kind of hobbyist activities where you actually learn how things work. Now, do you want to talk about the Model B?
Basically, there were two models created. The Model A was designed basically for more. Maybe it was more versatility.
It's more like a computer. It's more
Yeah.
a full functional computer. And the B is more for embedded systems. So
Yeah.
once you have developed a project, let's say that you want to track what your dog is doing during the week. You want the Model B for that. It's cheaper, it's lighter, it has lower power consumption. So the Raspberry Pi has an ARM chip that consumes very low power. So you can power it with a couple of batteries. So you can insert it in your cat coding and track what the cat is doing during the day. It's this kind of cool projects. So that board is cheaper because they kind of expect that you will get one and put it somewhere and not use it anymore. It gets dedicated to the project. Well, the A is more of a real functional computer. Is that what you said?
Yeah.
All right, so now what this brings us is that, well, I have a Raspberry Pi and he has a Raspberry Pi and we kind of build a friendship because he has one and Wes somewhere in the audience has another one. And it becomes this thing, okay, so we have another friend over there that has another one. So you build a community. And when I learned that you have a Raspberry Pi, I'm already thinking, what have you done with it? And that conversation is hard to have it here. It would be nicer if we have a space where we have tables and cables and soldering irons and stuff that we can break without getting sued and getting into prison. But that is not so dirty that it's a safety hazard. And if you find that space where you can get with friends and people who have the same interests, then you go back to what Tim was suggesting, a low pressure environment where you can learn with informal education. Go back to the actual curiosity of, let's see how these things work. Let's say what happened when we connect this cable here. And if it burns, well, it burns, I get another one, it's $25.
And I think another important element of that links the Raspberry Pi to the Hackerspace, and I think that I guess I could tie this in. Recently, there was a makerspace created in Troy, and I think that they kind of missed the hacker mark in that they started creating a structure, and it was I think they've actually done it so it's created a stressful environment, and you actually have to pay. I think the membership fee is like $180 a month. And I think that this links to the Raspberry Pi because the idea behind the Raspberry Pi was to try to make something that wasn't cost prohibitive. And I think that's what a hackerspace should be as well, is a place where people can come more or less for free, and they could play with stuff and learn and break stuff, and they don't have to worry about the next month's not being able to pay rent the next month because they just sunk money into a membership fee.
And so a lot of the things that we learned in the 80s, playing with computers, we never took classes to learn those things. You start hacking with your machine, and then we didn't have an internet at that time, so you talk to your friends, and they tell you, oh, I did this. And when you sit together with them, you see how they do things. You see how they type instructions in the command line. And you learn a lot by kind of transmission of information that goes side by side and not up to a professor in a stage on the stage kind of environment. And that's a very cool way to learn, and you learn a lot more. Many of you have been in TBL classes here, and TBL is kind of pursuing that to reconstruct that type of environment inside the classroom. So you learn from your peers, and you teach your peers, and the professor is more in the corner just in case somebody is trying to escape. So that's kind of the environment that you want to create in a hackerspace. Now this is...
And to jump off of that, there's actually, I'm not sure how many people are familiar with this, but there's this thing, this movie out there called Finland Phenomenon. And basically what a professor, I think it was the dean of either MIT or Harvard, had heard about Finland and how successful their educational system was. And basically they actually went over to Finland and asked them why their educational system was so successful, and they made an entire movie about it. And basically, the entire educational system is flat. There's no teacher standing up there and lecturing in front of the students. And this is from elementary school all the way up through. And the students who, all the students are kind of, there aren't really grade systems over there. All the students are kind of, are lumped together, and the students who pick up the material faster will teach the students who aren't picking it up as fast. And basically the conclusion of the movie was that it was this type of system that allowed students to not have as much pressure and not have to, and they don't have a grading system either. So they are actually more free to explore their education.
So one of the key elements in the recipe for creating a hackerspace is that you have to find that balance between being organized but not too organized, and being dirty but not too dirty. And it's hard to hit the right spot. So you may have to have some oscillations before you find the right combination. But look at this room. It's the kind of place where if you spill coffee in that table, that's okay. Nobody's going to yell at you because you spilled the coffee there. You don't want to start a fire. You can see that they have very elegant curtains. And they do the job. And they probably did that by themselves. They have duct tape. They probably built some of those tables by themselves. And what you're recreating in that case is an environment where if something breaks, you feel that you could fix it. And you don't have to fix it too well. So because that window is good enough. So then you are again in that low pressure environment where you have to put duct tape to get the thing running. That's fine. And then you learn how to put it back together. Well, if you were in a very formal environment, like here, when you spill coffee in that table, you are in trouble. If you burn the table, you are in trouble. When you sit in that room, you're afraid of saying anything that is wrong. So that's not conducive to learning and to sharing experiences. This is a power room. This is where somebody will sit in this chair here and tell the others what they are going to do. And they are going to say, yes, everything is going very well. That doesn't happen here. Here people are going to tell you there is fire in the other room. And then people will go to the room and take care of the fire and they will repair things the way they can. So this is the type of environment where we go back to what Tim is suggesting, reconstruct that feeling of curiosity, create an environment where you will just look at one of those devices and say, I wonder how this thing works inside. And after you say that, you just grab a screwdriver and open the thing. And if it breaks, well, too bad, you get another one. Now, something that is critical for this to work is that you have to have very small steps on the learning process. So your first interaction shouldn't be that you have to now learn the assembly code for the Raspberry Pi, the 50 commands and so on, in the same day at 1 hour, because that will bring you back to the stress environment. You want to have this very incremental process of learn this little thing, learn that other thing, in the order that you want. Something that Alex, for example, have been promoting is the notion that you pick your own adventure. So you don't have the curriculum that you have to follow. You pick what you're interested in doing today. You don't want this. You don't want to write to a hackerspace and be handed the manual of 500 pages that you have to read by tomorrow. Because that, again, takes the fun out of it. So you want to go back to this kind of environment where it's a little bit of the pressure of just playing with the things and see what they do. The work has to be enjoyable. It can be enjoyable. And a lot of the critical recipe for making it that way is that the difficulty, the incremental steps of difficulty has to be very small. When you look at game designers, they know the recipe. They know how to make you addicted to work for free. And they do it very well. If we manage to transfer this into education, we are in a very good shape. And it, again, goes back to creating that environment of low pressure, very easy things to do, things that you want to do more, and learn in the process.
And there's actually a company that takes this model called Valve. Valve is a rather famous game maker company, and they basically have a flat model. There's no CEOs or anything like that. And basically, from what I understand, where they do all their programming, it's an open area, and if you want to join a project, you can wheel your chair over to the project and join in. And they've actually been one of the more profitable companies because the people don't feel that stress. They don't feel the need to conform, and they feel free to just experiment and do what they like.
GitHub is another company that follows that model. So they break the hierarchical top-down control mechanisms, and they let people do and be creative. It means that you have to trust your people, let them do, you find responsible people, create a good environment, and create this system where they can talk to each other. There is horizontal communication that doesn't have to go and report to to the boss of the boss of the boss. So a workshop of this kind of hacker environment that we would like to set up here at SUNY is, so we are looking for a room, essentially. So if you know of a room that is, nobody knows of the room, that is close to a place with food, that has power, access to the network, and is not too clean but not too dirty, we will be looking for taking over a space like that, having some tables, having Raspberry Pis, having soldering irons, and engaging legal hacking activities where people can learn in a low-pressure environment. And so that's our, the pitch on, we would like to set up this kind of environment. It's something that you don't want to have the universities to set up for you, because then it's, again, for the top down. So it's something that you as students should own. You should find that room. You should take care of that room. It should be your place. You will decide what goes in there. And so you can actually have, again, that low pressure space of environment. Any?
We actually tried doing something similar to this at Starbucks. And needless to say, they didn't appreciate our idea of basically taking over multiple tables and starting to spread electronics equipment out. We didn't go as far as soldering. We figured that would have been overboard. But we have since moved. We tried to do an ad hoc here on campus. We have my group meets every Friday, or the first Friday of every month, and we meet in the commuter lounge. And a lot of times we bring our own equipment in, and that's a bit of a struggle because some of the equipment can be quite heavy. And dragging. One time I dragged my Dremel in and a bunch of other equipment, and it can be quite exhausting. So that's kind of why we were looking for a room that was more stationary where we could keep equipment.
So that's our pitch. We're looking for partners in crime. If you want to participate and you know of a room somewhere, let us know. If you have any questions about the Raspberry Pi or the Hackerspace, please. Yes?
I might have missed this in the presentation. Is this Hackerspace going to be open to non-SUNY students?
I think it should be. Now, yes, I think it should be.
Okay.
But again, it's something that the students should own. So kind of what I think that shouldn't matter too much. It would be up to them to decide if they want to have other people. I think there is a lot of value in bringing other people, especially, for example, people that are retirees. They have a lot of free time. They know a lot of stuff, and it's something that we have missed in the educational system is the interaction between the two steps in generations. Having the grandfather teaching the kids. So I think it should be, but yes.
Raspberry Pi more available now than it was like a year or 2 years ago. I remember trying to get it, and it was a year's wait.
It's getting better. You still have to wait, but you wait probably 2 weeks to get it.
2 weeks.
Yeah.
So don't try to get it just before Christmas, but it's getting better. And there is an effort to teach. What is the course?
Microprocessors?
With John Markle.
That's a fun class.
Yeah,
Oh, no, evening classes.
Yeah, on the fall, yes. They will be using for a 400 students class. All of them will be working on Raspberry Pis. But so it is easier to get them these days. But you still want to get them early on. You still cannot buy more than one.
I can comment on the availability. A coworker of mine ordered one a couple of weeks ago and shipped in a couple of days. So some suppliers do have them in reasonable stock, and I think otherwise the wait just might be a couple of weeks per month now. So it's not as bad as it was.
Another thing that you might want to keep an eye out for, it's a little bit more expensive, but there's a gaming platform coming out in June called the Ouya. And basically it's the same exact idea behind the Raspberry Pi. It's supposed to be open source, open hardware, and you're supposed to be able to hack it to your heart's delight. It's about $100, and they're actually going to be selling it at Best Buy, surprisingly. That's something I didn't expect.
Yes.
What was the class next semester that is with the Raspberry Pi?
Tima, do you remember?
It's the 100 level class.
It's 100 level?
Yeah, it's 100 level.
Oh, I can't do 100
Yeah,
level.
the introductory class. So the idea is to get, like, all these students just gradually.
And, you always can sneak in a
You can
classroom and sit in the back.
There's another microcontroller course.
I'm in the microcontroller class right now.
Yeah,
And then,
yeah.
and then my second question was, did you talk with the student government at all here about
I
the
haven't.
room space and stuff like that? You should have some student that's on there
That'd be
with
excellent.
informatics.
Yeah. Are you in touch with them?
Not now, not anymore, but I know a couple students that are, so I could find out.
Yeah, please, yes.
Alright.
Because that would be a good way to do it, yes. Yes, Chris?
Is the library seems like a natural partner for this? Have you guys talked with anybody over there yet?
No, no.
Because I know that the library has interactive media center and some other kinds of things. Not necessarily hackerspace in the same sort of way, but I think that right now in library science there's a strong emphasis on makerspace as a way to emphasize relevance and reach out to the community. So I think the library, you might find some people that are very receptive.
What's that called? What's that hacking club?
Good idea.
I know who the top is.
All right. Very good. All right. Thank you very much.
Sounds safer than the hacking club.
Legal hacking with the air